I am back, Dragons, with Activity 3.3, Factoring Algebraic Expressions. You have used the distributive property to multiply and divide algebraic expressions by a given value. The distributive property can also be used to rewrite an algebraic expression as a product of two factors, a constant and a sum of terms. You can write any expression as a product of two factors. In many types of math problems, you often need the coefficient of a variable to be 1. Let's explore how to use the distributive property without algebra tiles to rewrite expressions so that the coefficient of the variable is 1. Here's something we put in our interactive notebook. Using the distributive property to write the expression as a product of two factors is also known as factoring. In that instance, in the interactive notebook, I actually showed you with algebra tiles. Now this activity is asking us to do it without. Consider the expression 3x plus 6. Identify the coefficient of the variable term. Well, the coefficient is 3. That's found right there in front of the variable. Use the distributive property to rewrite the expression as the product of two factors, the coefficient and a sum of terms. I talked about this using the algebra tiles. Basically, you're finding the greatest common factor between 3x and 6. 3 is going to go on some outside of parentheses. 3 times what would get you 3x? And then 3 times what would get you 6? How can you check your work? Well, I think there's a couple ways here. The answer key says that you divided 3x by 3 and got 1x, and you divided 6 by 3 and got 2. That's what the answer key says. But I think substitution here would be an excellent way to know if you're correct. For example, 3x plus 6 is the original expression, and we factored it out and did 3 times the quantity of x plus 2. Now, if we made up a value for x such as 1, we could simply substitute that in and see if we end up at the same answer. So here we'd end up with 3 times 1 plus 6, which is 3 plus 6, which is 9. And here, if we try that substitution method, we would do that, which would bring us to this, which would bring us to that. As you can see, the expressions are in fact equivalent. Using the distributive property to rewrite the sum of two terms as the product of two factors is also referred to as factoring expressions. In the expression 3x plus 6, you factored out the common factor. I brought that up. I said greatest common factor between the two terms of 3 from each term and rewrote the expression as 3 times the quantity x plus 2. In other words, you divided 3 from each term and wrote the expression as the product of 3 and the sum of the remaining factors. You can use the same strategy to rewrite an algebraic expression so that the coefficient of the variable is 1, even if the terms do not have common factors. Let's see what they've got here. It says, remember, you can multiply or divide any expression by 1 and not change its value. Yep, that is the identity property. Let's rewrite the expression 4x minus 7 so the coefficient of the variable is 1. Let's see what they try here. To rewrite the expression, factor out the coefficient 4 from each term. The equivalent expression is the product of the coefficient and the difference of the remaining factors. All right. They do 4x minus 7 equals 4 times 4 over 4 times x minus 7 over 4, which simplifies to 4 times the quantity x minus 7 fourths. This one's a tough one. They're trying to show you that by using this improper fraction, you can still make this coefficient 1. And the reason they want to make that coefficient 1 is when you're using equations and inequalities, it's easier to work with 1. Use the distributive property to check that the new expression is equivalent to the original expression in the worked example. They want us basically to take this and work it back out. So multiply that and multiply that. So that'll be 4 times x there, minus 4, remember 4 is over 1, times 7 over 4. So that's going to equal 4x minus, if you know how to cross cancel at all, that's what you're getting. So yes, it's equivalent. I could multiply these out the long way if you needed me to. It's 4 times 7 is 28. 1 times 4 is 4. 28 divided by 4 is also 7. So yes, they're equivalent. Rewrite each expression as the product of two factors. What they want here is factoring. You're trying to find the greatest common factor between the terms. Sometimes that's easy, sometimes it's not. I'm looking at number 1, and that's one that's similar to this unusual one. They want us to pull out 4. And then do x plus 5/4. If I redistribute that, you'll see that the answer is correct. Here I could pull out 8 and do x minus 3/8. Here I could pull out 1/2 x minus 8, because 1/2 of 8 would have been 4. Here I can pull out 1.1. It'll be x plus 1.1. Think about 11 times 11 is 121. That's kind of what we've created here. So that's factoring. These are unusually hard. Oftentimes you won't run into these fractions. The factoring we did in the interactive notebook is more relevant to the work you'll need to do in 6th and 7th grade. Appreciate you joining me for activity 3.3. I'll be back with 3.4 shortly.